Okay, at the end of the last lesson, I gave you this for homework. I have this elevator with two buttons, and what I want to do is have this elevator continuously go up and down until these buttons get pressed. So it'll go up, button will hit, then it'll go down, button will hit, back and forth, and we have this elevator motor. Okay, so let's go ahead and work through that. So I'm just going to redraw a sketch of this elevator. We have button 1, and we have button 2, and we have some sort of elevator motor. And let's say the max is 100, that's the max power is 100, and the max negative power is negative 100. So that's our range. You could have used anything. Max power, max negative power, 100%, negative 100%, whatever it is. You can even run it slowly, right? It doesn't need to be running at full speed. Okay. So for starters, I want this thing to keep going up and down continuously. So I want it to have an infinite loop. So in my pseudocode, I will start with a while true. And I'll put a little bracket indicating the start of what's happening in here. You don't need to use a bracket. You could circle things. It's really your choice. While true, I'm going to have an infinite loop. Now what I want to do is while this button is not pressed, it's going to run up. But also, as it's in the middle, let's say, this is my second floor, this is my first floor. As it's in the middle, neither button's getting pressed, and I need to continue in a direction. I don't want it to, just hit and then move off and then hit again, then move off. If I did something like, if button 1 is equal to 0, meaning the button's not pressed, the top button's not pressed, E motor equals 100, and then else E motor equals negative 100. Your instinct might be to do something along these lines. But if you think about what would happen if this is the code I ran, the elevator would move up. It'll keep moving up till this button gets pressed, right? Because it's going to keep looping and checking. Is the button equal to 0? Yes. Okay, it's still going to equal 100. Is the button? Yeah. It's going to keep looping until this hits. Then once it hits, it will say, okay, the button is now equal to 1, so this is not true. So it's going to go to this else, and the elevator is going to start running down. But it's going to loop back to the start. And then once the elevator starts moving down, eventually it's going to disengage this button, and button 1 is going to equal 0 again. And before it reaches the bottom, it's going to set the elevator motor value back to 100, and this elevator is going to start moving back up again. So this thing, if we ran a code like this, the elevator would move up, hit the top, and then go down a little bit, and hit the top again, and just do this. It's just going to shudder at the top. We need it to hit the top, and then hit the bottom, and then hit the top, and then hit the bottom, and then hit the top, and then hit the bottom, back and forth, back and forth. So this program right here is no good. And, I think some people did something like this, and that's okay. That's an understandable mistake. But let's talk about how we would actually make something like this work. Well, one option is we can say while true. So again, we want an infinite loop, so this goes forever. And then we're going to put a nested loop, a loop inside of that while loop. So we'll say while button 1 equals 0, the elevator motor equals 100. And then while button 2 equals 0, elevator motor will equal negative 100. So something like this would work, because if you think about it, as long as this, let me zoom out a little bit so we can see the elevator. As long as this button is not pressed, so we start, right? This button is not pressed, the elevator is going to run up. It's going to run up at max power, 100, right? 100%. And it's going to keep going through this until what happens? Until this button gets pressed up top, until this reaches floor number 2. and then and only then will it proceed to the second part. These will not happen simultaneously. It's stuck in this loop until that top button gets pressed. Okay, so this runs up, that top button gets pressed, button 1 is now equal to 1, so this stops. We exit this loop, and we go down to this bottom loop. While button 2 equals 0, if we're at the top, if we're at the second floor, button 2 is going to be equal to 0, and it's going to run this. The elevator motor is going to run at negative 100. It's going to run down, and it's going to keep going in here until this button gets pressed, until this Boolean, button 2 equals 0, is no longer true. So we run down, and it hits. Then once it hits, it exits this, and we reach the end of our code, but we're in an infinite loop. So we loop back to the top. And now this thing can cycle back and forth without getting stuck. Now there are other ways you could have achieved this. This was just, I think the simplest way to do it. But, I'm going to look over your homework, and hopefully I see one that's even simpler that I couldn't think of. Now, for today's lesson, our aim is to continue working with pseudocode by using analog sensors. Now, last time we did pseudocode using digital sensors. This elevator code, this is using digital sensors, 0 or 1, only options. But we're today going to go and we're going to talk about pseudocode using analog sensors. The analog sensor I want to use, the theory of, is the ultrasonic rangefinder or sonar sensor, or otherwise known as a distance sensor. Let me pull up an image for you guys of what I'm talking about. That's what it looks like. And there are these two, see if I can kind of point to them if I'm clever. There are these two beacons, and they send out a sound wave, and based on how long it takes for that wave to return, you can tell how far a certain surface is. Now we can utilize this to drive an object a certain distance away from something. There are many applications for this sensor, but let's say I wanted to use it in order to, get my robot a certain distance from a wall. Let's say 1 foot. So what would the pseudocode look like if I wanted to get the robot to drive till it was 1 foot away from a wall and then it just sat there? So I would start by, telling, while, and I'll say the variable for the sonar sensor, whatever the output of it is, while SNR, so sonar, while sonar is greater than or equal to 12 inches, right motor equals 100, indicating max speed or some speed, left motor equals negative 100. And then after that's done, while it's greater than 12 inches, it's going to keep going through and setting the value to 100, 100, 100. Then once it's done, I would set right motor equals 0, left motor equal to 0. Now another option for how you can achieve this is you could say if you put a while loop that runs forever, while true, if the sonar is greater than or equal to 12 inches, right motor equals 100, left motor equals 100, else right motor equals 0, left motor equals 0, and that would, let me just get this out of the way so it's not distracting us. either of these would work. It would take your robot and move it till it's a foot away from the wall, and then stop it from moving. Now let's take it a step further. Let's say we wanted to use this sensor to keep it exactly 1 foot away. Exactly 1 foot away from the wall. So, meaning if it overshoots, it would come back, or if someone pushed it towards the wall, it would come back. No matter if it was too close or too far from the wall, it would move in order to be that correct distance apart. What would that look like? So let's describe the problem, because this is what your homework is going to be for today. Let's say you have your robot. Right now what I have is I have a robot and I have a wall. And it's going to move until it's 12 inches away, wherever that is. That point, 12 inches away. But what if the robot starts here? The code I have right now, it won't move back. So that's no good, because it doesn't satisfy that situation. Also, it doesn't handle the situation of what if this robot overshoots? You know, it's these robots aren't perfect at stopping in real time. You know, it takes a second or two for it to fully decelerate and stop to a halt, because you're not really, giving reverse. You're not applying a brake. You're just setting the motor value to 0. You're not putting in more juice, but it's going to keep coasting a little bit, and it's going to overshoot, especially if you're traveling fast. The further away you're traveling for, the more time you have to accelerate, the faster you're going to be going when you come to a stop. So for homework, what I want you to do is I want you to create pseudocode that utilizes the sonar sensor in the same way, same fashion that I did. Write pseudocode for a robot that travels to 12 inches from a wall, regardless of where it stops, that can handle both of these situations and will correct itself if it overshoots. So the variables you're going to be working with, you're going to have sonar. That's going to give you a value in inches. And you're also going to have right motor, which is going to be your right side, and left motor, which is going to be your left side. So, making the robot go forward and back. And that's it. You should be able to do this using just loops, conditionals, booleans, pseudocode. Okay, so that's what I want you to work on. I will see you guys next time when we will review this.